right, Andrew. Intermediate value theorem. Do you know how many theorems are on the EP calculus exam?
31.
4. Here's one of them, right? Within about a month, Andrew, you're going to know all 4 of them. Ready?
Yeah.
So, this one might take a minute to write down, but here we go. All right. If f is a continuous function on the interval a to b, and f of a does not equal f of b, right? And k is any number between f of a and f of b, and here's the kicker. Andrew, Mr. Baker's here to help explain this to you today. This is why I get paid the big bucks. Thank you for laughing. That was good. Okay? This is the intermediate value theorem. Now, this might look intimidating, but it's really not.
Got it.
Okay, it's really not. Carter, you almost got it done? Almost copied down?
Almost.
Molly, you got it all copied down? 12, you got it copied down yet?
Almost.
Are you 12?
Yes, sir.
Thank you, Colin, for responding. I was calling you. I was just, never mind. That was good. That was like perfect.
It was perfect. That was so funny.
All right, so there we go. All right, Colin, let's just break this down. It'll make a lot of sense. You ready? Colin, you ready?
Yes, sir.
Let's just break this down. If f is a continuous function on an interval a to b. All right, well, let's draw a graph. Here's a, here's b, and let's just say I drew this function like that right there. Carter, does that function look continuous? Right? No holes, jumps, gaps, asymptotes, nothing, right? That's a continuous function. So I just took care of that first part. The next part says f of a cannot equal f of b. So it looks like the way I drew this. Here's f of a. Here's f of b. Do those look like the same values?
No.
No. Right? All right, so I've drawn a graph that's continuous. F of a doesn't equal f of b. And then they say k is any number between f of a and f of b. So k can be anywhere in here. And just for fun, I'm going to put it like right there so you can see. Okay? K is any number between f of a and f of b. Then there is at least one number c. So c is in between a and b right here. There is at least one number c on that interval such that when you plug c into the function, you get k. Don't you usually plug in x coordinates to get y values? Right? It's like when you plug in c, you get k. How many times, Andrew, does it look like I hit the graph? Yeah, you know, I mean, like this would be like one c. This would be another c, right? This would be another c. That's why they say there's at least one c in that interval, such that really they're just saying the graph will hit k at some point in that interval. That's what it's really talking about. Now you might still be like, Mr. Baker, that still doesn't make any sense to me, and that's okay because this is the first day of it. But Jack, here's how they use it most of the time, right? I have to say most of the time, you know, the smiley face right here, okay? Most of the time, it's a graph that makes a whole lot of sense. Because they'll say like A is here, and they'll put a dot. You know what I'm saying? Here's f of a way down here. And then they'll put a dot over here, B, and then they'll say f of b is over here. What's the most important thing, Emily, we've ever learned in Algebra 2, Pre-Cal, Calculus? It's all about just this thing right here, and where the graph, what do we call those things?
Zeros.
X-intercepts, zeros, exactly, right? This is how the intermediate value theorem applies. What if f of a was negative and f of b was positive? Did I have to cross 0 in here somewhere? You know what I'm saying, Carter?
Yeah.
If f of a was negative, f of b was positive, I had to cross 0 somewhere in there. And that's really what the intermediate value theorem is all about. Like, there had to be some number c. There's at least one number c in that interval such that f of c equals 0 in this case, right? We had to cross 0 at some point in that interval because one was negative, the other one was positive. Go team. That's basically how they use the intermediate value theorem. Lucy, you ready for some applications?
Sure.
And Ashka, what about you?
Yeah.
Okay. All right. Well, example number 1 here. How are we going to use this? I want you to show that all right. I want us to show that f of c will equal 0 in that interval from 0 to 1 for this function. Okay? Show that f of c equals 0 in that interval, that f of c will equal 0 in that interval for that function right there. So, Andrew, because there's 4 theorems, and you're going to hear me talk about this all year long, you know what the other theorems really kind of, talk about? Starts with a D word. Derivatives. Derivatives are huge in calculus. You know what I'm saying? There's 3 major concepts in calculus: limits, derivatives, and integrals. You know what I'm saying?
Yeah.
So, have I talked about derivatives at all? It's the IVT. Are they going to tell you on the exam, use the IVT to prove this? No, you have to deduct what they're doing. You know what I'm saying? So, here we go, Andrew. You ready?
Yeah.
Here's how you get full points on your quiz on Monday, or full points on an AP calculus exam. You got a question? No, you're good. All right, so Andrew, here's how it works. If f is continuous on the interval, is that a cubic function?
Mm-hmm.
Are cubic functions continuous?
Yeah.
Should you state that the function is continuous?
Yeah.
By golly, let's get that first point right here. F of x is continuous, right, on the interval from 0 to 1. That is a true statement, right? That is the one requirement for the IVT. All the other theorems basically say it has to be continuous and differentiable, but we haven't even started talking about derivatives yet, okay? So all this one requires is that it's continuous. This is a cubic function. Cubic functions are always continuous. So there we go. The next part of the sentence, Andrew, says, talk about the endpoints. Should you mention the endpoints on this?
Yeah.
Well, why not? Just come over here and be like, well, Mr. Baker, those are the endpoints, A and B. So you're just like, okay, what's f of 0? -1. What is f of 1? 2, right? Obviously, these 2 endpoints don't equal each other. You know what I'm saying? After you have verified that, I'm going to show you how to take this long sentence and just write it eloquently. You ready? Yeah. All right. This is why you shouldn't be late to first class of abstract algebra. You ready? All right. By the IVT, there exists a C contained in the interval from 0 to 1, such that f of c equals 0. Why? Because, you can even put because, this is perfectly acceptable mathematical notation, because of this right here. And I'm going to let you catch up, and I'll say it a few times, but that's going to get you full points easily on an FRQ. And honestly, are all the other theorems going to follow this exact same kind of setup?
Yeah.
Yeah. Once you know this little sentence, you can write this 10 times faster than you can write a bunch of stuff from over there. You know what I'm saying?
Mm-hmm.
So, Carter, By the IBT, there exists, that's what the backwards Z means, right? There exists a C. This is a symbol for element of or contained in. You're basically saying there exists a C contained in this interval, right, from 0 to 1, such that, that's perfectly acceptable. All my college professors would use that all the time. And then, such that f of C equals 0, because they said show f of C equals 0, right? Because of this. Now this is the kicker on IBT. They love this stuff. Why does this make sense? Why did we talk about the endpoints? What was f of 0? -1. Did f of C have to be 0 at some point if you're between -1 and what? 2. That's what the IBT is talking about. I was negative here. I was positive here. Well, by golly, I had to cross 0 at some point. And there's some C value in that interval that guarantees that. Okay? Cool? Hazel, what do you think? You don't like the backwards Z. I know. It takes a minute for a lot of people to get used to it.
I keep thinking ace.
What'd you say?
I keep saying like the backwards Z and then ace, and I know it's not ace, but I
No.
keep
Yeah, there exists a C and that contained in that interval.
Wait, so do you have to remember how to write it like that?
Yeah.
Okay.
Once you do, it just goes
Yes.
just real fast.
Right.
All right, let's do another one. Andrew, you ready?
Oh, yeah.
Andrew, because this is my last example, I have to talk to Jack today. Good.
You don't have to.
Yes, I do, Jack. All right, Jack, let's talk about example 2. All right, Jack, here we go. We're going to show that f of C equals 6 on this interval. And we're going to use this function right here. All right, we're going to use that function right there. All right, so Jack, you got this on your quiz on Monday. We got to go through these steps. What's the first step you should do on the quiz on Monday?
Probably
What
see
should-
if it's continuous.
You should say this is continuous, right? Is this function continuous on that interval? You should politely pump the brakes for a moment. Just like, wait a second. We've been doing graphs like that all week, right? We've been graphing these things, and we're like, holy cow, where's our only point of discontinuity on this graph?
At x equals 1.
Because there's a vertical asymptote of 1. But good news, is 1 in that interval?
No.
No. So you know what that means? Like, we might have a vertical asymptote of 1, but basically, guess where this graph is continuous?
On the interval.
On the interval. It's continuous everywhere else, right? So, do we get to state that this function is continuous?
Yes.
Yes, we do. We can go ahead and say, you know what? F of x is continuous, right? On that interval, 5/2 to 4. Cool. What's the next thing we need to do, Jack?
Check the endpoint.
Check the endpoints. You're like, okay, I need to make sure that f of a does not equal f of b. And here's where you get to have a little fun, because I know everybody loves fractions. All right, Jack, you ready?
Oh.
I'm plugging in 5/2, bro. Okay? You got this.
Okay.
So, Jack, what's 5/2 squared?
25 over 4.
Very good. 25 over 4. I'm about to add it to 5/2, so should I get like a common denominator, maybe?
Yeah.
So 25 over 4 plus 10 over 4 is
34 over 4. Wait, hold on. You know, I feel good about that. Wait, sorry, 34. Sorry. Wait. Okay. I'm done. Can somebody help me?
25 plus 10. Jack.
35.
It's late in the day. It's Friday, Jack. I forgive you.
Thank
Okay?
you.
I forgive you.
Do you want to let somebody else put it on?
No. You're good, Jack.
Okay, yeah.
So, Jack, 25 over 4. 4 plus 10 over 4 is 35 over 4, right? Right? What's 5/2 minus 1? Or 5/2 minus 2 over 2?
3/2.
3/2, right? What do you do when you have a fraction over fraction?
Ooh. Keep change flip.
I hate that saying. Great. You flip and multiply. You flip and multiply, right?
Oh, it's 10.
Jack, slow down. Jack, relax.
Sorry.
Okay, Jack, cross reduce. Can you cross reduce the 2 and the 4?
Yes.
Yes. You can go 1 here, 2 there. You can't do anything with the 35 and the 3. So final answer here would be 35 over 6.
That's not 10.
It's not 10, but it's okay. So Jack, you cool with that?
Yeah.
I'm not really better with that.
Sure.
All right, Jack, let's do the next one. If I wanted to do this endpoint right here, right, this would be f of 4, right? And you're like, okay, I got 4 squared plus 4 over 4 minus 1. You cool with that, Jack?
Yes.
What do you get?
Wait, right now? Okay. 20/3.
Thank you.
Thirds?
4 squared is 16. 16 plus 4 is 20. Over 3, boom. Now,
Oh, I think I did 23.
Jack. Every now and then, Mr. Baker has some people in calculus, you know, they're like, Mr. Baker, that's 5 and 5/6. Do we write mixed numbers in calculus? No. They gave you something to talk about in middle school. You know what I'm saying? Now, but Andrew, is it good to visualize this?
Yep.
This is 5 and 5/6, right?
Right.
Technically, that's what?
6 and 2/3.
6 and 2/3. It's good to keep the mixed number part in the back of your brain because this makes a lot of sense now. If I'm at 5 and 5/6 and I go to 6 and 2/3, did I equal 6 at some point in that interval? Obviously. I obviously did, right? So because I said it's continuous, because I checked the endpoints, we are ready now, Andrew, for our sentence. So you're like, okay, by the IVT, right? There exists, you got that backwards E again, right? There exists a C in the interval of 5/2 to 4, right? Such that f of C will equal 6 at some point, right? Because I know that f of 5/2 is basically 5 and 5/6, and I know that f of 4 is 6 and 2/3. I obviously had to equal 6 at some point in that interval. And that's what that sentence, that's what that IVT expression is talking about. Okay? Because I verified that this was 5 and 5/6, and I verified that that's like 6 and 2/3, f of C being 6 has to be somewhere in between those two values. That's what the IVT talks about. But Jack, I gotta kick it up just one little notch. You ready? What happens if they said, Jack, you ready? What if they said solve for C?
Well,
I want to know what C value makes this function equal what?
6.
So I should do what with this function? And 6.
Set of equal.
Yeah, here we go, Jack. You ready? Got x squared plus x over x minus 1 equals 6. Yeah, Jack, what are we doing? I gotta solve for x, bro.
0, 0.
Yeah.
Pull out the x from the numerator.
Stop it.
Multiply by the conjugate. Multiply by x minus 1.
Ding, 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 ding. Jack, if I was looking at this expression, right, because this is kind of like the first time we've done an expression like this in calculus, nobody likes fractions, right? So you obviously, instead of dividing by x minus 1, you would want to,
Multiply.
right? So if you multiply both sides by x minus 1, right, that's why that cancels over here, and you're like, ooh, x squared plus x equals 6x minus 6. Come on, this is going back to Algebra 1 days. What did your Algebra 1 teacher tell you to do?
Put everything on the same side.
Set it equal to
0?
0.
Yeah.
Yep, put everything on one side, which means set it equal to 0, Jack. So you would like subtract the x over, right?
Yeah.
If you subtracted 6 over, you get 5x. If you added the 6 over, you get 6. And the whole reason why you set it equal to 0 is because we can do everyone's favorite thing called factoring. Jack, what factors of 6 add to 5? Negative 5? What factors of 6 add to negative 5?
-3, -2.
That's good. -3 and -2. Right? Which one of these is actually in that interval? So C is 3. What do you think, Jack?
fractions are hard, but everything else is good.
Sorry. IVT. That's fun stuff.
Good times, great oldies.
That's it for today.